Before we start, we need to know what is Newton's law of cooling. Basically, Newton's law of cooling states that the temperature of an object changes at a rate proportional to the difference between its temperature and the surrounding temperature. When the temperature difference is large, the object changes temperature faster. So, over time, the object will slowly cool down or warm up until it reaches the same temperature as its surrounding.
Application of Newton's law of cooling. First is forensic science, time of death estimation. It is used to estimate the time of death by measuring how a human body cools after death compared to the surrounding temperature. Second is food safety. It helps determine how quickly cooked food cool to a safe storage temperature to prevent bacterial growth. Third is engineering and mechanical system. Engineering uses to analyze how machine part of or engine lose heat after being switched off.
Move on to the next one, which is the formula that we will use in our Newton's law of cooling calculation. It is dT over dt equals to K in bracket T minus Tm. So, what is all of this? First, we have Tt, which is the temperature of the object at time t, while Tm is the temperature of the surrounding object. Next, dt over dt is basically the rate of change of the temperature, and K is the constant of proportionality. Last but not least, we have T minus Tm, which is also means the difference between the object temperature and its surrounding temperature.
The body is quite cold already.
Well, I don't think there is any injury.
Are you the one that called us?
Yes, I was the one who found her. When did you think the time of death is?
Let's calculate using Newton's law of cooling.
The problem statement is a student arrived at a classroom at exactly 8 a.m. and discovered her lecturer lying motionless on the chair. She immediately contacted the police and a detective came to investigate the scene. Upon arrival, the detective measured the lecturer's body temperature and found it to be 70 degrees Fahrenheit. 2 hours later, the detective measured the body temperature again and recorded it as 60 degrees Fahrenheit. If the room temperature was 50 degrees Fahrenheit, and assuming that the lecturer's normal body temperature before that was 98.6 degrees Fahrenheit, determine the time at which the death occurred.
To find the answer, we must use mathematical method for law of cooling. Firstly, we need to write down the information given from the question. So, the initial temperature is 70 degrees Fahrenheit. Therefore, T of 0 equals to 70. After 2 hours, the body temperature is 60 degrees Fahrenheit. Therefore, T of 2 equals to 60. And the ambient temperature is given as 50 degrees Fahrenheit. Therefore, Tm equals to 50. Next, substitute Tm in differential equation to solve for capital T using the method of separable variable. Thus, the temperature at any time t is given as T of t equals to Ce to the power of Kt plus 50. To find C, we use T of 0 equals to 70. Therefore, C is 20. Next, to find the value of K, we use T of 2 equals to 60. Therefore, K is approximately equals to negative 0.347. Now, the equation of the temperature is given by T of T equals to 20e to the power of negative 0.347 T plus 50. The question wants us to find the time of death occurred if the body temperature before death was 98.6 degree Fahrenheit. Therefore, we write as T of T equals to 98.6 and we substitute it in the equation and solve for the time T. Therefore, T is negative 2.559, which means negative 2 hours 34 minutes. This indicates that the time of death occurred 2 hours and 34 minutes before 8 AM. Therefore, the time of death approximately 5:26 AM.
So the time of her death is 5:26 AM.
Your cup of coffee changes temperature at a rate proportional to the difference in temperature between itself and its surrounding. How long will it take your cup to reach 50 degrees Celsius if it starts at 85 degrees Celsius in a 20 degrees Celsius room and reaches 70 degrees Celsius in 5 minutes?
Before we solve this question, let us jot down all the information given from the question. First, there is Tm, which is temperature of the surrounding object equals to 20 degrees Celsius. And then, there is temperature of object at time 0, which is initial temperature equals to 85 degrees Celsius. There is also temperature of object at time 5 equals to 70 degrees Celsius. And last but not least, they gave us temperature of object at time t equals to 50 degrees Celsius. Now, using the same mathematical model from question 1, we will substitute all the information and rearrange it. And then, we will integrate on both sides. Later on, we will simplify and we will get T equals to 20 plus CE power of KT. Now, we will be using T0 equals to 85 and substitute it into our newest equation. And then we will get C equals to 65. Using the same equation, we will substitute T5 equal to 70 and we will also substitute value C. After simplifying it, we will get K equals to negative 0.052. And now we are left with TT equals to 50. We will substitute into the same equation and substitute all the other information we also have, which is K and C, and we will simplify all the steps and we will get the time, which is T equals to 14.87 and we will round off to 15 minutes. And therefore, it takes approximately 15 minutes for the cup of coffee to reach a temperature of 50 degrees Celsius. In conclusion, our problem statement clearly shows how the temperature difference between an object and its surrounding gradually decreases until thermal equilibrium is reached, which defines Newton's law of cooling. This principle is important because it helps explain everyday heat transfer processes and allow us to better predict how temperature changes over time.